we have a polynomial f of x, which in factored form has three linear factors. X minus 3 is linear, x minus 1 is linear, x plus 4 is linear. This means, of course, if you were to graph y equals x minus 3, or y equals x minus 1, or y equals x plus 4, you'd get a straight line graph. So we have three linear factors. Now, a polynomial, every polynomial, is a product of linear and irreducible quadratic factors. Not every polynomial will reduce to just linear factors, but if it doesn't, the other factors are quadratic. Okay, we don't need to say too much more about that. Just to put this in context. Okay, we got three linear factors. Now, we want to graph this polynomial. What do? Well, let's first find the intercepts, that is, the x and y intercepts. The y-intercept occurs when x equals 0, as we should know very well by now. So, letting x equal 0, we get negative 3, negative 1, and 4, which multiply out to 12. So f of 0 equals 12. That's our y-intercept. So our y-intercept is going to be at the point 0, 12. And here we have it. X-intercepts are also easy to find when the polynomial is in factored form. Okay, when x-intercepts occur when y equals 0, which means, of course, that if y equals f of x, then y being 0 means these three factors multiply out to 0. So y would equal x minus 3 times x minus 1 times x plus 4. And if y is 0, then that would equal 0. Now we use the zero property of multiplication. And the zero property of multiplication is really pretty much just common sense. We have, if we plug in a value of x, we get three numbers here. And if we multiply those three numbers together, we're going to have to get 0 in order to solve this equation. What does it tell you? If the product of three different numbers, and these numbers will be different because whatever x is, we're subtracting or adding different numbers to x. So we get three different numbers. Now, if three different numbers have a product of 0, what do we know? Well, what we know is the only way we can multiply numbers to get 0 is if one of those numbers is 0. So if we have three different numbers, one of those three numbers has to be 0, and if one of those three numbers is 0, the product will be 0. So x minus 3 could be 0, or x minus 1 could be 0, or x plus 4 could be 0. If x minus 3 is 0, then x is 3. If x minus 1 is 0, then x is 1. If x plus 4 is 0, then x is negative 4. So now we have the three values of x that make this product 0. And we put those on the x-axis. Negative 4, 0, 1, 0, and 3, 0. And that 1 is kind of obscured, so let's make sure we can see it. Now, we haven't proven it, but this function gives us a continuous graph. Okay? Every value of x, for every possible real number x, we can evaluate this function. We get a point on the graph, and the graph moves from point to point continuously without jumping. It can't be equal to 12 at some value of x, and then at the very next value of x, it can't be like negative 50. Okay, we can't jump around. Okay, it's a continuous graph. Now, if this is a continuous graph, then the only way it can change sign from positive to negative, the only way it can get from positive to negative is to go through 0, which means that the only places this function can change its sign from positive to negative or negative to positive would be at x equals 3, x equals 1, or x equals negative 4. So we have a depiction of the graph here, and this isn't necessarily what the graph will look like, but we know that to the left of 4, there's no place where the y value is 0. And if the y value is not 0, any place to the left of negative 4, then the sign, the plus or minus, the sign of the y value can't change, which means that to the left of 4, the function is either always positive or always negative. And between negative 4 and 1, there's no place where the function can change from plus to minus or minus to plus. There's no place where the function is 0, so there's no place where it can go from negative to positive or positive to negative. You can only do that when the value of the function is 0. So between here and here, we know that the function has to always have the same sign. Okay? To the right of 1, between 1 and 3, it's always got to have the same sign for, again, the same reason. And to the right of 3, it's, again, always got to have the same sign. Now, we know we have this point, this point, this point, and this point on the graph. And this red dotted line represents one possible behavior of this function. It could start negative, meaning it would be negative all the way to the left of 4. From negative infinity through 4, this function would have to be negative. From 4 through 1, well, we know that it has to be positive between negative 4 and 1 because we have the point 0, 12 on the graph. And if there's one point in this interval where the value is positive, then the function has to be positive at all points on that interval because, again, it can only change sign here or here. Okay, then it could go from positive to negative at this point and be negative on the interval from 1 to 3, and then it could be positive to the right of 3. But that's not the only possible behavior. Here I've sketched a possibility in purple. The graph is down here, it comes up to 12, down to 1, and it dips down below the axis, but it comes back up to 3, 0, and just touches this point, so it's 0 at this point, and doesn't change sign. It doesn't have to change sign. It can touch at this point, turn around, and go back down. Now, we haven't determined what this function does, but it could do this, or it could do something like this. We have to do some testing to find out. So what we do, we make the statement that just summarizes what I just said. F of x has the same sign for every x from negative infinity to negative 4. The same is true on the interval negative 4 to 1. The same is true for any x in 1, 3. And the same is true for x in 3, infinity. That is, on each of these intervals, this interval, this interval, this interval, and this interval, this function has to have the same value at every point. Okay, let's go ahead and figure out what the sign is in the interval from negative infinity to negative 4. We can choose any x in the interval from negative infinity to negative 4, evaluate this function at that value of x, and determine from the value whether the function is positive or negative. Well, the suggestion somebody made in class is, well, let's just let x equal the next negative number, negative 5, and that's a good choice. There's actually another choice that you could make that would give you, that would give you additional information about the graph, but we'll stick with x equals negative 5 just to illustrate how we can test. Again, that was a good choice. Okay? If x is negative 5, then, well, f of x equals f of negative 5, and you can verify that if we plug negative 5 in here, we get negative 8 for this factor, negative 6 for this factor, and negative 1 for this factor. All three are negative, so when we multiply them together, we get a negative. So before even multiplying the numbers, we can tell that the graph is going to have to be below the x-axis. We're going to have negative values all the way from negative 4 to negative infinity. Now, these multiply out to negative 48, and we might use that number in graphing, but that number might be beyond the scope of the graph that we want to actually draw. Might or might not. Okay? The point, though, is that this is negative. This value is negative, so the graph is below the x-axis from negative infinity to 4. Okay. In the interval from negative 4 to 1, what's a reasonable choice, or what's an easy choice for evaluation? Well, if we let x equals 0, we can do that, and we get f of 0 equals 12. Of course, we already got that when we found the intercepts. So we already know that it's the graph is above the x-axis between negative 4 and 1. But if we didn't know that, 0 would be a good point to choose. Evaluate it, we find that it's positive, so the graph is above the axis from x equals negative 4 to x equals 1. Now, if we use x equals 2 for the interval from 1 to 3, and 2 is the only integer we can use because, of course, 1 and 3 are on the axis here because they give you 0. We wouldn't get any information by using 1 or 3. We let x equals 2, and we evaluate the function. And you can do this yourself. You clearly get a negative. Now, looking at this, the reason I can say we very clearly get a negative without even evaluating, 2 minus 3 is negative, but 2 minus 1 is positive, and 2 plus 4 is positive. So we have a negative times a positive, giving us a negative, and the graph will, in fact, go below the axis, as we've seen. Now, we've seen that the graph doesn't behave like the purple graph. It doesn't come down from above and just touch this point and go up. It comes up from below because it has to be negative to the left of 4. Now, we still don't know what's going to happen at 3. Can the graph come up and make a turn like this and end up going down, or does it have to come up through 3, 0 and then go up? Well, for this interval, I'm not going to choose like x equals 4. I'm going to choose a nice round number that's a lot bigger than the last 0 we have, than the 3. Okay, so I'm going to pick a number, 100, that's out there a lot further from the y-axis than the 0.30. You'll see why in a minute. So if I choose x equal 100 for the interval 3 infinity, I get f of 100 is what? 100 minus 3, 100 minus 1, 100 plus 4. It's 97 times 99 times 104. That's close to 100 times 100 times 100, which is what? 100 times 100 times 100 is 1,000,000. It's a very big number, miles high on the scale of this graph. Now, we understand that 97 is pretty close to 100, 99 is pretty close to 100, 104 is pretty close to 100. Some of those numbers a little more than 100, some a little less. But we know that if we multiply these out, we're going to be pretty close to 1,000,000. So that if we go out to x equals 100, okay, which isn't all that far out, probably out in the next hall someplace, we're going to have to go up many miles to get to the point on the graph. So the graph is not only going to be positive, that's easy to determine because all these numbers are positive, but it's going to get very steep.